Hi guys, so today we'll be solving this problem called minimum number of operation to move all balls to each box. Let's read the problem. If n boxes, you are given a binary string boxes of length n, where boxes of I is 0, and if the ith box is empty, and one if it contains one ball. In one operation, you can move one ball from a box to an adjacent box. Box of I is adjacent to box of j if absolute of I minus j equal to 1. Note that after doing so, there may be more than one ball in some boxes. Return an array answer of size n, where answer of I is the minimum number of operation needed to move all the balls to the ith box. Each answer of I is calculated considering the initial state of the boxes. Right. So in this problem, we've been given a string which has ones and zeros. One denotes uh, that there is a ball present at that index, and zero represent that there is no ball present at that index. And we need to know, or we need to return the minimum number of operations needed to move all the balls to that ith index or not. So, for example, here I want all the balls to be reaching here from here from here, right? And I want to know the minimum number of operation needed to do that, right? So let's do that. Let's see how we can do it. So for example, in the first one, so we have one here, right? And I have ball here as well. So I need one operation to come here, right? There is zero here, so I don't need any operation. So the answer for the first one is one, right? For the second one, I have similarly, let me use some other color. So I have one here, right? So I have to move one from here to here. So there is only one operation which I need to do. For the last one, I need to move this one here, right? So one operation plus I need to move this one here and then this one here, right? So there is two operation, right? So that is equal to 3. So the last answer is 3, right? And that will be the answer for it. Like that idea of moving the ones from either if it's left or right depending on the index, we need to move that, and also consider the operations for moving that one or ball from the ith index, from the end whatever index we are on, to the ith index that we are considering, and we need to return the minimum number of operations required to do that, right? So the idea would be simple. The intuition that I have for solving this problem is that I'll maintain, like, I'll be traversing, so this is the string, so 0 1 2. I'll be traversing from left to right and right to left, right? So how will I do that? So I'll keep the number of balls to the left and number of balls to the right. So that will be essentially be the count of balls. So this one, when I'm traversing from left to right, this will count the number of balls to the left. So that will be that will be tracked in the balls to the left, and balls to the right will be for considering the balls or balls at the ith index from right to left, right? And I'll also maintain move left and move right, which is essentially our answer. So answer is basically move left or move right, whatever it is. So it is the move left and move right denotes the operations required from moving a value from left to the ith index or right to the ith index. By that I mean, because I'm maintaining balls left and balls right, right? So when I'm at, let's say I'm at this position, I'm at the zeroth position, at the last position, at the third, right? At that place, I have a couple of options to do. So I have to move this to here, right? Or I can move, or I can definitely, do other things as well. But I need to move all this to here, right? And how I can do that is very simple. I can have balls to the left, right? So at balls to the left at this position will be just be 1, right? And when I'm at this position, sorry, and when I'm here, it's going to be 0. When I'm at this position, I have 1 ball to the left. And when I'm at this position, I have 2 balls to the left, right? So 1 from this and 1 from this. And moves to the left will be tracking the, the operations required for moving these balls to the right or to the left, whatever, depending on what we need to do here. So yeah, that is the idea. We need to maintain balls to the left and balls to the right. That will keeping the track of how many balls are there in the left or right, right? This is what it's denoting. And move left is essentially adding, adding, adding the balls to the left and keeps on adding that until we move or reach the last index, whatever, or the first index. Move to the right is for the first index and move to the right left is for the last index. Let's get to the coding part in order to understand this a bit more better. Let's get to the coding part. First of all, I'll maintain n, which is length of boxes, right? And then answer equal to 0 into n, which is basically the size which arrays of all the answers of length n, right? I'll maintain two variables, as I said, left and right. One will be for balls to the left, moves to left, balls to right, moves to right, right? And in this, I'll be doing certain things. So first of all, I know that I need to keep on adding the moves to left to the answer of I, whatever it is, right? And balls to left will essentially be nothing but the boxes of I, whatever it is at that index, right? And moves to left will keep on adding the number of balls to left that needs to be added, right? Similarly, I'll have j, which is n minus 1 minus I. This is essentially for the right pass, like whatever we need to iterate from right to left, right? So answer of I, answer of actually j equal to moves to right. That is the idea. And balls to right is int of boxes of I, right? And moves to right is equal to balls to right, right? So we'll add that to moves to right value, right? And then in the end, we just return the answer for the final answer, right? And yeah, this one is basically traversing from left to right, putting everything in the balls to left. And every time we are traversing one step ahead, I always need to add all the balls to the left, right? That's why I'm adding it to moves to the left, which is basically our tracking our operations, and moves to right is tracking the right operations from the right, right? So yeah, that's the idea. Let's run the code, and this one is actually okay, right, because we are traversing from right to left. So let's run the code to see if everything is working fine. That works. Cool. I hope you guys understood the problem. Thank you.